Inductive reasoning is when you use specific information to make a broader generalization. And whether you realize it or not, it's something that you do all the time. Later, when we learn about deductive reasoning, you're going to see that deductive reasoning is just the opposite, using a generalization to make a specific statement. So, when you make a generalization, that's called a conjecture. So, for example, if every time it rains they have to reschedule the Yankee game, that would be an example of a conjecture. And the inductive reasoning part comes in with, well, I used the specific games in which it rained and they had to reschedule the Yankee game to make the broad generalization that, well, every time it rains they have to reschedule the Yankee game. Now, conjectures are not necessarily true until they're proven. Now, all it takes is one counterexample to disprove a conjecture. So, to the previous statement I just made, if it rains, the Yankee game must be rescheduled. A counterexample would be, well, the Yankees might be playing in under a dome that day, so if it rains, they don't have to reschedule the game. Another thing to know about inductive reasoning is that it's all about looking for patterns. So, let's try a few examples. Let's do this one together. A good way to think about inductive reasoning is to relate it to how babies learn about the world. So, in this scenario, little Timmy touches the stove and cries because it's hot. A few days later, he does it again, and again he gets burned by the stove, no pun intended. Now, Timmy has learned that all stoves are hot, so he just made a conjecture. He recognized a pattern with two specific stoves to generalize that all stoves are hot. So that's a good way to think about inductive reasoning. Here's another example. Let's say we have these specific prime numbers, 3, 5, 7, 11, and 13. And we want to make a conjecture about them. So we'll say, alright, since all those numbers are prime and they're all odd, I'm going to assume that if a number is prime, then it is odd. Now, again, remember, conjectures are not necessarily true until you prove them. So, a counterexample could be found with this conjecture, and that counterexample would be 2, because 2 is a prime number. It fits the first part of the statement, but it's not odd, so it doesn't fit the conclusion. Just to help you understand counterexamples a little more, 3 and 4 are not counterexamples. 3 is not a counterexample because it does fit the first part of the statement, and it's also odd, so it just helps prove the statement, so it's not a counterexample. 4 is not a counterexample because it's neither prime nor odd. So once it's not prime, it doesn't fall under this conjecture, since the conjecture starts with if a number is prime. So if you wanted to make a new conjecture, you could say that if a number is prime and greater than 2, then it is odd. But just know that you can't assume that's true either until you've proven it. Now I'd like you to try an example on your own. So, try to make a conjecture about this sequence below, 1, 1, 2, 3, 5, 8, and 13, and use it to predict the next number. I'm going to pause the video and then hit play when you want to see how you did. Alright, well, if you did not get this next number in the sequence, then you've probably never heard of the Fibonacci numbers. So, what they are is, you take the two previous numbers, add them together to figure out the next number. So to get 2, the third number in the sequence, you would add 1 plus 1. To get 3, you would add the two numbers in front of 3, 1 plus 2. To get 5, you would add 2 and 3, the two previous numbers in front of 5. To get 8, you would add 3 and 5, the two numbers in front of 8. To get 13, you would add 8 and 5 to get the next number. So to get the next number that comes after 13, you would add 8 plus 13 and get 21. One more example I want you to try, and that has to do with counterexamples. So, in this statement, I'd like you to try to think of a counterexample, or if you think there aren't any, then that is also an acceptable answer. So pause the video, think for a few seconds, and then hit play when you want to see how you did. Alright, so it says, if the sidewalk is wet, it is because it rained. So, to find our counterexample, you have to find ways that the sidewalk could be wet that are not related to rain. So, one thing could be, say, a sprinkler. A sprinkler can make a sidewalk wet, and it's not rain. Any other example like that is also acceptable. Alright, thank you for watching, and have a good day.